Hello everyone, my name is Antonio and I'm lab coordinator and fab instructor at OpenDot Milan, Italy. Today I want to talk about face shields and how we at OpenDot approach the production of this PPE during the COVID-19 crisis. As you know, face shields were one of the most replicated projects around the maker community and the Fab Lab network. And this is because, first of all, they're quite useful to healthcare professionals, and also because they were quite easy to replicate with the tools of productions that we have inside the Fab Labs. We studied several versions of the same product, and we figured out a way to make our own and speed up the production of it, in order to make dozens of them in a single day. This was possible through three approaches. First of all, we adapted the nozzle of a 3D printer to become quite larger. Then we adapted the design and the slicing settings. And finally, we hacked some G-code in order to automate and replicate the process. I'm going to show you how in the next minutes.
Chi mi ha rubato il coso?
That are going now, the last ones, or is there more after that?
Hmm?
The prints that are going.
I think I have something, but
Let's start by customizing our nozzle. We took one of the spare nozzle inside our lab, and we wanted to clean it thoroughly in order to have a better result. So we took it and put it in front of a blow torture. In this way, all the plastic will melt down and leave it unclogged. You would know that the result is good when the brass nozzle will reach a color like an intense red. At that point, all the plastic inside of it would have melted or burned.
ce l'hai il color rosso.
Yes, è bellissimo. I colori sono spaziali.
Ok, adesso mi muovo giù, l'appoggio sul piatto.
Ah, ok.
Now the nozzle is totally unclogged, but as you can see, the brass has developed a sort of patina over it.
Vai.
This could be troublesome for our 3D printing operations, so all you have to do in order to clean it is to dip it inside vinegar. Leave it a few seconds and you can see the patina will move away. Now the nozzle is unclogged and clean and it's time to drill it. The best way to do so is with a ladle, but a tower drill will do the job more than fine if you're precise enough. Be sure to clamp it firmly and put it precisely under the center of a drill. Now you have to pierce a hole through the center of the nozzle. Be sure to move firmly and slowly, otherwise you risk to break up the drill bit. Once the drilling is finished, it's better to polish the surface of the nozzle, otherwise little flaws on the brass or the brittleness could risk to ruin the 3D printing process. And we've done so by putting the nozzle on a power drill and rotate it over an automatic sander. In this way we were sure to have an homogeneous and straight surface. Here's the final result. And it's time to look at the design specifications and the printing settings. This is the face shield that we designed, inspired by many other face shields we found online. It's specifically adapted to the purpose of our 3D printing. Consider that we're using Ultimaker Cura as a slicer software and Ultimaker 2 Plus as a 3D printer, but the same things I'm going to explain can be useful also for different softwares or 3D printers. The first and the most important thing to do, especially in Ultimaker Cura and if you're using one of the latest version, is to change the G-code flavor that you're going to output. This is because otherwise certain values, such as temperature, cannot be defined within the slicer, but can only be managed from the 3D printer. From the printer settings, change it from Ultimaker to Marlin. This is the printing profile that I have already set up to make my job. Let's see what are the parameters that I have adapted. Let's start with the layer 8 that I set up to 0.35 and the initial layer 8 as 0.6. The line width instead is set up to 1 mm. These are values that are adapted to our nozzle width, otherwise they wouldn't work in any way with other 3D printers. And they are what can grant us a really faster printing process. In the shell section, I'm setting the wall thickness to 1 mm. In this way, also the wall line count will set to 1. The top-bottom thickness are set to 0, so they are not going to be printed. It's fine to set the infill to 0%. In this way, we're going to get only the walls of the model. In the material section, you find the printing temperature value. This is perhaps the most critical value, because it has to be tested according to your machine, the material you're going to print with, and the nozzle width. We found out that 253 degrees is enough temperature to make the PLA flow nicely. And we've set the build plate temperature to 50 degrees. In this way, once finished, the model will be detached easily. Along with temperature, print speed is another important value. We set it to 35 mm per second. It's slower than a default print speed, but it's compensated by the larger volume of material printed, and the overall result is a much faster job. Let's remind that we're kind of walking on the razor's edge with all these customizations. So, in order to get a more firm initial layer, we want to print it at a much slower speed, specifically at 25 mm per second, in order to grant it more steadiness. It's essential for the later steps of replication to avoid any kind of support or any brim or skirt, so we remove them from the settings. And finally, we want to spiralize the printing process. In this way, it will be faster and more robust. You do so by setting the Spiralize Outer Contour option on. With this printing profile, I was able to downsize the printing process from 1 hour to 24 minutes. Now, it's time to look at the G-code hacks that we're going to use in order to replicate and automate the wall printing process. You can open G-code files with any text editor. At the first look, G-code might look like a big bunch of spaghetti code, but with a little bit of habit, it will be easy to understand it. For the purpose of this tutorial, there are just few things that you have to understand. The first one is that all the lines beginning with a semicolon are just comments, so they will not be interpreted by the machine. They are really helpful both for debugging and for setting some memos inside the code. M140 is the command for setting the build plate temperature. G1 instead are the commands for moving the extruder, so you have to define the X, Y, and Z movements inside this command. What I want to achieve with my hacks is the replication of the wall printing process and the detachment of the model once the printing is finished. Let's see how it's done. Through the help of some comments that I left before, I look for the part where I've written the detachment operation. As you can see, in this wall block I've defined a series of G1 movements. They are set so that I can move the extruder in different positions that will push away the printed model outside of the 3D printer. There's a lot of guesswork behind these instructions, and after a long trial and error fine-tuning, I found the perfect movements for my machine. They should be set up according to your specific 3D printer. Don't just copy-paste them. In order to help the detachment, I've also set a cool down of the build plate down to 20 degrees. This is set around the 75% of the code to give enough time to the build plate to get to room temperature. Okay, we've defined the model detachment. Now, how can I repeat the wool printing process? Well, there are two ways. One is to insert a command called M999, which repeats the wool printing process from scratch once it's done. But this command is not supported by every machine, so we can rely on a different trick. I've just copy-pasted the whole code several times in the same file. In this way, I can repeat the wool printing as many times as I want. For example, in this file, I'm repeating the printing process 6 times. This is enough to give me a whole batch of products and not to risk some of the downfalls that you might incur into when you have 2 long jobs. So let's save our G-code file and run it on our 3D printer. Finally, calibrating a 3D printer is more important than ever with that new nozzle, especially if you're using a custom one. This is our 3D printer going insane. Don't worry, it's totally fine, it's just overflowing. And it's printing time. Let's check just the first layer and give him some time to make his job.
Il video rimane fermo perché è in manuale.
Non abbastanza. Forse vediamo se ce la fa ora.
Witnessing a fully working detachment for the first time is nothing short of amazing.
So, this is it. Here's our final results. Do you like them? They're pretty neat, isn't it? Okay, I hope you enjoyed watching this tutorial, and I hope you're going to replicate the things that we've shown you at your own or within your Fab Lab. And if you have any other suggestion on how to speed up certain processes, please share them. We are totally eager to know more about these kind of things that makes our tools so special. Hope to see you next time. Ciao!
If you want to know more about this tutorial, check out our website. And if you have any other tricks or suggestions in order to speed up a printing process, let us know on our Wikifactory forum. Thank you for watching.